Welcome back to the problem solving session on the topic fuzzy C-means algorithm with the help of objective function J-mean. So in this case we are considering 4 data points, namely 1, 3, 2, 5, 4, 8 and 7, 9, and we are going to split into two clusters, namely C1 and C2. And initial step we are going to initialize or assume the membership values for first data point 1, 3. It belongs to first cluster with a probability of 0.8 and it belongs to second cluster with a probability of 0.2. This 0.8 and 0.2 we are going to call further it as membership value. Same way data point 2, 5 belongs to first cluster with a membership value of 0.7 and second cluster with a value of 0.3. Third data point belongs to first cluster with a value of zero point 0.2 and the data point belongs to cluster number 2 with a membership value of 0.8. And fourth data point belongs to first cluster with a membership value of 0.1 and the second cluster it belongs to second cluster with a membership value of 0.9. And step number 2 we are going to find out the mean with the help of an equation Vij which is equal to sum of k equal to 1 to n be the number of data points. In this case it is 4. We have only 4 data points where mu ik power m into zk divided by sum of k equal to 1 to n mu ik power m. This mu ik is nothing but membership value and m is the fuzziness parameter. In this case we are going to use it as 2 for our easy purpose, and the zk indicates your each individual data point. So second step is to find out the mean. So with the help of the equation Vij, first mean you are going to calculate V11 which is equal to, for first data point it is 0.8 square. How that 0.8 square comes? 0.8 is the membership value, mu ik value, and m is nothing but the fuzziness parameter. In this case we are going to consider it as 2, that is 0.8 square into zk parameter value. First data point you are going to consider the x values alone. In v11 we are going to consider in all 4 parameters data points we are going to consider the x values alone. So it is 0.8 square into 1 plus 0.7 square into 2 plus 0.7 square into 4 plus 0.1 square into 7 whole divided by the whole term of membership value by the square term. You need to sum it up all. 0.8 square plus 0.7 square plus 0.2 square plus 0.1 square. If you simplify you will get V1 as 1.568. Same way do it for V12. That is 0.8 square into, you need to consider the second y term in each data point, 0.8 square into 3 plus 0.7 square into 5 plus 0.2 square into 2, sorry 0.2 square into 8 plus 0.1 square into 9 whole divided by the membership value square term. So you will get 4.015. This is for V11 and V12. Now we calculate for V21 and V22. For V21 it is 0.2 square of second cluster. V21 indicates second cluster first value. 0.2 square into x term 1 plus 0.3 square into 2 plus 0.8 square into 4 plus 0.9 square into 7 whole divided by 0.2 square plus 0.3 square plus 0.8 square plus 0.9 square. So if you simplify you will get 5.35. Same way for V22, if you simplify you will get 8.215. So now you get the mean centroid of two clusters, namely V1 as first cluster and V2 for second cluster. It belongs to 1.568 and 4.051, comma for V2 it is 5.35, comma 8.215 respectively. Now we need to calculate out the mean distance between the data points and the this V1 and V2. Fine, mean 1 and mean 2. For first data point alone, let me calculate. For first data point is 1, 3 and the mean of 1 is 1.568, 4.051. So by Euclidean distance method, let me calculate the distance of D11 which is equal to square root of 1 minus of 5.68 the whole square plus 3 minus 4.051 the whole square. If you simplify you will get 1.2. For first same way for P12, how you will calculate D12? First data point versus mean 2. So it is square root of 1.535 the whole square plus 3 minus 8.215 the whole square, you will get 6.79. Same way you need to calculate for D21, D22, that is between the second data point and the mean 1, second data point versus mean 2, and third data point versus mean 1, third data point versus mean 2, fourth data point versus mean 1, and fourth data point versus mean 2. If you calculate, you will get the answer. If you see this first data point, if you consider for mean 1, you are getting 1.2. It is less compared with D12. So it belongs to 1 category. Same way for second D21, D22, see here it is D21 is less. Mean it is less. Mean 1 is less. So it belongs to mean 1 category 1.04. So if you see D31 and D32, it is something interesting. It is D31, it belongs to mean 1. Same way for D41 and D42, it belongs to D42, which is less. It is less. D42 is less, so it belongs to second mean. So which is less, you need to consider that. Same way for D31, D32, 1.36 is less, so it is belongs to second group. Fine. Okay. Now we are going to update the membership value using the in step number 4. We are going to update the membership value mu ki, which is equal to inversely proportional to the relative distance, that is 1 by summation j equal to 1 to n of dki the whole square divided by dkj the whole square into 1 divided by m minus 1. In this case m is 2. In this case we are going to consider the firstness variable as 2, and you have in this case you have only 2 clusters, so n is also 2. So this j value varies from j equal to 1 to 2. So in denominator you will get 2 terms. Let me see. For first data point, let me consider. Already we have calculated the D11, D12 in previous step, and we know the value of this membership value we have assumed in earlier in step number 1. With that, we are going to calculate the mu1, update the membership value of mu11, which is equal to k value is 1, I value is 1. So it is 1 divided by d of k is 1 and I is 1. So d11 square whole divided by d1, j is 1. Initially it is 1. So d11 square plus, if you expand one more term you need to do. So it is in numerator, there is no j term. So repeat the same term again. So it is d11 square divided by d, k value is 1, now j value is 2. So d12 the whole square, and whole power 1 by 2 minus 1, it is 1. So 1 by 1 again it is 1. So mu11, if you simplify, you will get 0.97. So previously the membership value of first data point with respect to first cluster is 0.8. Now it is updated to 0.97. Namely, second thing, for point number 1 with second cluster, we are going to see mu12, which is equal to 1 divided by d of, in this now the value of I is 2, right? So k is 1. So d12 divided by d11 the whole square. Initially j value is 1. J starts from j equal to 1 plus d12 square divided by d12 square and whole power 1. If you simplify, you will get mu12 is equal to 0.03. Initially the cluster first data point belongs to cluster 2 with a probability membership value of 0.2. Now you have this second data point belongs to cluster 2 with a probability value or mean value of membership value of 0.03. Same way do it for remaining data points. For 0.7 earlier the data point 2 with the first cluster was 0.7. Now it is updated to 0.95, and same way for second data point belongs to cluster 2 with a probability or membership value of 0.3. Now it is updated to 0.05. Same, namely repeat the process for mu31 and mu32. You will get 0.08 and 0.92, and for this case earlier it was 0.1, now it is 0.06, and earlier it was 0.9, now it is 0.94 percentage of value. It is belongs to cluster number 2. Now the membership value is updated. This was the previous one, and now it is updated membership value. Fine. Kindly cross verify with your answer. Now we are going to calculate the main process of objective function. Now we are going to calculate this part alone. We know the cluster mean of two clusters of V1 and V2, and we need to calculate this Vi first. So this plays a major role. Zk minus Vi the whole square into A. For that, what we need to do? We need to calculate for first point of all V values we need to find. So V1, which is equal to, see here, Zk is nothing but your data parameter first value, x value, minus of 1 minus of V1 first value, it is 1.568 the whole square, plus second value 3 minus of 4.015051 the whole square. If you simplify, you will get 1.426. That value you need to write it here for first data point versus mean of first cluster. You will get value distance as 1.426. Namely, proceed for second case, V2, which is equal to first data point 1 minus of 5.35 second cluster mean, right, and 3 minus 8.215 the whole square. You will get V2 is equal to 46.10. Do it for remaining data points and you will get the remaining values. Kindly cross verify from your side. Now we have done with this value. Fine. Now we are done with this particular value. This square term gets over, still A is there, right? Okay, we can do that. So J min objective function, which is equal to, where this 0.8 square comes, it is comes from here. 0. Previous iteration. We are going with previous one to find the objective function of old membership value. Then only we can check the new membership value objective function is increasing or decreasing. Now we can go with the initial assumption membership value. So you will get 0.8 square into 1.426 plus 0.2 square into 46.1 plus 0.7 square into 1.087. This value is this term, plus 0.2 square into 21.51 plus 0.8 square into 1.864 plus 0.1 square into 54 plus 0.9 square into 3.345. If you simplify, you will get J min, the objective function J min of first 0th iteration as 10.53. And now proceed for second iteration number 2, right? You need to repeat from step number 2. We need to calculate Vij, that is updated cluster mean. You will get it as 1.509 and 4, and V2 dash as 5.35 and 8.215, and repeat the process from step number 2 and calculate the V1 and V2 for the new updated one. If you do that, for V1, how to calculate the V1? It is first data point 1 minus of 1.509 the whole square plus 3 minus of 4 the whole square. If you do that, you will get 1.2678. This is the difference between the distance difference between first data point and the cluster V1, first center, right? If you repeat that, you will get J min of first iteration, which is equal to 0. This is a new membership value, 0.97 square into 1.26 plus 0.03 square into 550.79 plus 0.95 square into 1.23 plus 0.05 whole square plus 24.72, and repeat the process till the last one. You will get J min of 1, which is equal to 7.06. If you see the J min of first iteration and the 0th iteration, the J min of first iteration is 7.06. It's reduced. That means the solution is improving. The step is moving towards a converging point. At some point in another 2 to 3 iteration, it's going to converge at some particular point. But if the value gets J min of 1 gets increases, that means we are doing in a wrong way. It's a takeaway. So the J min objective function should be reduced. Thank you. We'll meet in another video.